An all-electric home presents specific requirements for branch circuits, especially within the kitchen area. When a laundry area is located within a kitchen closet, the National Electrical Code, or NEC, dictates the minimum number of branch circuits needed to serve the kitchen adequately and safely. Let's break down these requirements to understand why the answer is 3 branch circuits. Firstly, the NEC requires at least 220 amp wall appliance branch circuits to serve the kitchen countertop receptacles. These circuits are specifically intended to supply power to small appliances such as toasters, coffee makers, blenders, and other portable devices commonly used in a kitchen. The purpose of having 2 separate circuits is to prevent overloading and to ensure that multiple appliances can be used simultaneously without tripping a breaker. These 2 circuits must serve only receptacle outlets at the countertop, in the kitchen, pantry, breakfast room, dining room, or similar area. They are also permitted to supply receptacle outlets for refrigeration equipment. Note that there are exceptions. These small appliance branch circuits are permitted to supply outlets in addition to those specified. Secondly, a separate 20 amp branch circuit is required for the laundry area. This is because the laundry area, particularly when located within the kitchen or a nearby closet, has its own dedicated power needs primarily for the washing machine. The NEC mandates a separate circuit to handle the load imposed by the washing machine, which can draw a significant amount of current during operation. This ensures that the washing machine does not interfere with the operation of other kitchen appliances or create a potential overload situation. The laundry circuit must serve only the laundry receptacle outlet. Now, let's consider why other options are not the minimum. Option A, which suggests 2 branch circuits, is incorrect because it only accounts for the small appliance branch circuits and neglects the separate requirement for the laundry area. Option C, which proposes 4 branch circuits, might be applicable in certain situations with additional appliances or specific local code requirements, but it is not the minimum requirement according to the NEC for the described scenario. Option D, suggesting 5 branch circuits, would only be necessary if there were additional high-power appliances or specific circuit needs beyond the standard requirements for the kitchen and laundry area. To summarize, the minimum number of branch circuits serving an all-electric home with a laundry area located in a kitchen closet is 3. 220 amp small appliance branch circuits for the kitchen countertop receptacles and 120 amp branch circuit dedicated to the laundry area. This configuration ensures electrical safety, prevents overloading, and complies with the NEC guidelines for residential electrical installations. The importance of adhering to these NEC requirements cannot be overstated. Proper wiring and circuit allocation are essential for preventing electrical fires, protecting appliances from damage, and ensuring the safety of the occupants. When designing or modifying electrical systems in a home, always consult the latest edition of the NEC and local electrical codes to ensure compliance. It is also advisable to consult with a qualified electrician to ensure that the installation meets all applicable requirements and is performed safely and correctly. Additionally, consider the potential future electrical needs of the kitchen and laundry area when planning the electrical system. If there is a possibility of adding more appliances or increasing the electrical load in the future, it may be prudent to install additional circuits or increase the capacity of existing circuits to accommodate these changes. This can help prevent the need for costly and disruptive electrical upgrades in the future. In conclusion, understanding the minimum branch circuit requirements for an all-electric home kitchen with a laundry area is crucial for ensuring electrical safety and compliance with the NEC. By adhering to these guidelines and consulting with qualified professionals, homeowners can create a safe and functional electrical system that meets their needs and protects their property. Let's delve deeper into the specific NEC sections that govern these requirements. NEC Section 210.11 C1 covers small appliance branch circuits. It states that in addition to the general lighting and appliance circuits, 2 or more 20 amp small appliance branch circuits shall be provided for all receptacle outlets specified by Section 210.52. B1. This section outlines the requirements for receptacle outlets in the kitchen, pantry, breakfast room, dining room, and similar areas. These small appliance branch circuits must serve only the receptacle outlets specified in Section 210.52. B1 and are permitted to also supply receptacle outlets for refrigeration equipment. However, they are not permitted to serve other outlets. NEC Section 210.11 C2 addresses laundry branch circuits. It requires at least one additional 20-amp branch circuit to supply the laundry receptacle outlet or outlets required by Section 210.52. F. The section specifies the requirements for receptacle outlets in laundry areas. The laundry branch circuit must serve only laundry receptacle outlets and have no other outlets. It's important to note that the NEC provides specific requirements for the type and placement of receptacle outlets in kitchens and laundry areas. For example, countertop receptacles must be installed so that no point along the countertop is more than 24 inches from a receptacle outlet. This ensures that appliances can be easily plugged in without the need for extension cords, which can be a safety hazard. In laundry areas, at least one receptacle outlet must be installed within 6 feet of the intended location of the washing machine. This provides a convenient and safe power source for the appliance. When installing or modifying electrical systems in a home, it is essential to use the correct type of wiring and components. All wiring and components must be listed and labeled for their intended use and must be installed according to the manufacturer's instructions. This ensures that the electrical system is safe and reliable. Additionally, it is crucial to properly ground all electrical circuits and equipment. Grounding provides a path for fault current to flow back to the source, which helps to prevent electrical shock and equipment damage. The NEC provides specific requirements for grounding electrical systems, and it is essential to follow these requirements carefully. Furthermore, consider the use of arc fault circuit interrupters, or size, and ground fault circuit interrupters, or GFCIs, to further enhance electrical safety. ASIs are designed to detect and interrupt arc faults, which are a common cause of electrical fires. GFCIs are designed to detect and interrupt ground faults, which can cause electrical shock. The NEC requires ASIs to be installed in many areas of the home, including bedrooms, living rooms, and dining rooms. GFCIs are required in areas where there is a high risk of electrical shock, such as bathrooms, kitchens, and outdoor locations. In addition to the NEC requirements, local electrical codes may have additional requirements or restrictions. It is essential to check with the local building department to determine the specific requirements for electrical installations in your area. Remember, electrical work can be dangerous, and it is always best to consult with a qualified electrician if you are not comfortable performing the work yourself. A qualified electrician has the knowledge and experience to ensure that the electrical system is installed safely and correctly. They can also help you to select the right type of wiring and components for your needs and ensure that the installation complies with all applicable codes and regulations. When selecting an electrician, it is essential to choose someone who is licensed and insured. This provides assurance that the electrician has the necessary qualifications and experience to perform the work safely and competently. It also protects you from liability in case of accidents or damage. Before hiring an electrician, ask for references and check their online reviews. This can give you an idea of the quality of their work and their customer service. It is also a good idea to get multiple quotes from different electricians to compare prices and services. When you have found an electrician you are comfortable with, make sure to get a written contract that outlines the scope of the work, the price, and the timeline. This will help to protect your interests and ensure that the work is completed to your satisfaction. In conclusion, understanding the minimum branch circuit requirements for an all-electric home kitchen with a laundry area is crucial for ensuring electrical safety and compliance with the NEC and local electrical codes. By following these guidelines and consulting with qualified professionals, homeowners can create a safe and functional electrical system that meets their needs and protects their property. Consider also the long-term implications of electrical consumption within the kitchen and laundry areas. As technology advances, newer appliances may have different electrical demands. Planning for potential upgrades or increased usage can prevent future electrical issues. For instance, energy-efficient appliances, while beneficial in the long run, might have specific startup current requirements that could affect circuit load calculations. Similarly, smart home integration, which is becoming increasingly popular, could add to the overall electrical demand in these areas. Furthermore, consider the layout of the kitchen and laundry area when planning the electrical system. The placement of outlets should be convenient and accessible, and the wiring should be properly protected from damage. It is also essential to ensure that there is adequate ventilation in the laundry area to prevent moisture buildup, which can damage electrical components. Moreover, be aware of the potential for electromagnetic interference, or EMI, from appliances and other electrical devices. EMI can interfere with the operation of electronic equipment and can even cause damage. To minimize EMI, use shielded wiring and components and keep electrical devices away from sensitive electronic equipment. Remember that electrical systems are complex and potentially dangerous. It is always best to consult with a qualified electrician if you have any questions or concerns. A qualified electrician can help you to design and install a safe and reliable electrical system that meets your needs and protects your property. Firstly, ensure proper planning and adherence to codes. Secondly, use quality materials and components. And thirdly, have professional installation and regular maintenance to ensure a safe and efficient electrical system.